Space is vast, filled with mysteries. From the swirling galaxies to the enigmatic black holes, the universe is a treasure trove of wonders waiting to be discovered. Among these celestial marvels, one place stands out, capturing the imagination of scientists and dreamers alike. But few places capture our imagination like Europa. This icy moon, orbiting the gas giant Jupiter, has intrigued humanity for decades. This moon of Jupiter isn't some cratered rock. Its surface is a frozen expanse marked by cracks and fissures, hinting at the dynamic processes beneath. Beneath its icy shell, scientists believe a hidden ocean exists. This subsurface ocean, kept warm by tidal forces from Jupiter's immense gravity, could be teeming with life. An ocean that could be larger than all of Earth's seas combined. Imagine the vast, unexplored depths, stretching for miles beneath the ice. Science fiction writers have long imagined life in Europa's depths. Giant creatures, bioluminescent organisms, perhaps even intelligent beings. The possibilities are endless and tantalizing. While we haven't found any evidence of that yet, the possibility is thrilling. Scientists are constantly developing new models and simulations to understand what might lie beneath Europa's icy crust. And it's why scientists are so eager to explore this alien sea. Missions are being planned with probes designed to pierce through the ice and explore the ocean below. What makes Europa so special? It's not just the potential for life, but the unique conditions that make it a prime candidate for exploration. The answer lies in its potential for life as we know it. Life needs liquid water, a source of energy, and the right chemical ingredients. Europa's ocean, with its potential hydrothermal vents, could provide all these essential elements, and the right chemical ingredients. Scientists are particularly interested in the chemical composition of Europa's ice and ocean, which could hold clues to the building blocks of life. Europa might just have all three. The cracks on its surface could be pathways for nutrients and energy to reach the ocean below, creating a habitable environment. But reaching Europa is no easy feat. The journey is long and fraught with challenges. It orbits Jupiter, a giant planet with a dangerous secret intense radiation belts. These belts can damage spacecraft and pose a significant challenge for any mission aiming to explore Europa. Despite these challenges, the quest to explore Europa continues. With each new mission, we get closer to uncovering the secrets of this enigmatic moon. The dream of discovering life beyond Earth drives us forward, pushing the boundaries of science and exploration. Jupiter is a powerful force in our solar system. Its gravity is immense and its magnetic field is enormous. This magnetic field traps charged particles, creating intense belts of radiation around the planet. These radiation belts are like invisible death traps for spacecraft. They can fry electronics and damage instruments. Any mission to Europa needs to contend with this hazard. Imagine trying to study a delicate flower while standing in a hurricane. That's the challenge of exploring Europa in Jupiter's radiation. But scientists have a plan, a mission designed to withstand the onslaught. Enter the Europa Clipper, NASA's ambitious mission to unlock Europa's secrets. This spacecraft is designed to study Jupiter's moon Europa, which is believed to have a vast ocean beneath its icy surface. Scientists are eager to understand more about this mysterious moon, as it could potentially harbor conditions suitable for life. The Clipper won't orbit Europa directly. Instead, it will take a more strategic approach to avoid the intense radiation belt surrounding Jupiter. That would expose it to too much radiation, which could damage its instruments and shorten its mission lifespan. The radiation around Jupiter is extremely harsh, and prolonged exposure could be detrimental. Instead, it will perform a clever dance. This involves a series of intricate maneuvers designed to maximize the scientific return while minimizing the risks. The spacecraft will orbit Jupiter in a highly elliptical path. This elongated orbit allows it to spend most of its time away from the dangerous radiation zones. This allows it to swing by Europa repeatedly, gathering data during each close encounter. Each flyby will provide a wealth of information about Europa's surface and subsurface. Then, it will zip back out to a safe distance from the radiation. This back-and-forth motion ensures the spacecraft remains operational for as long as possible. Think of it like a ship sailing around an island. The ship can't dock because of dangerous reefs and rocky shores. The ship can't dock because of dangerous reefs. These hazards make it too risky to stay in one place for too long. So it circles, sending out small boats to explore the coastline. These smaller vessels can get closer and gather detailed information without the same level of risk. That's the Europa Clipper's strategy. By carefully planning its orbits and flybys, the mission aims to uncover the secrets of Europa while keeping the spacecraft safe from harm. Why go through all this trouble? Why invest so much time, effort, and resources into exploring a distant moon of Jupiter? Because beneath Europa's icy surface, scientists believe a global ocean exists, potentially teeming with life. This isn't just a wild guess, it's based on years of data and observations. This ocean isn't just a thin layer, it's a vast, deep expanse of water, shielded by a thick crust of ice. It could be dozens of miles deep, holding more water than all of Earth's oceans combined. Imagine the possibilities in such an immense body of water. But it's not just the amount of water that's exciting. The real intrigue lies in what this water might harbor. It's what might be in it. Could there be life forms, perhaps even complex ecosystems thriving in the dark, cold depths of Europa's ocean? On Earth, wherever we find liquid water, we find life. From the boiling hot springs to the freezing polar ice caps, life finds a way. Even in the deepest, darkest parts of our oceans, life thrives. Creatures have adapted to extreme conditions, surviving without sunlight. Could Europa's ocean be any different? Could it be home to strange and wonderful creatures, adapted to a world without sunlight? Could it hold strange and wonderful creatures, adapted to a world without sunlight, perhaps even bioluminescent beings, lighting up the dark waters with their own glow? The possibility is too tantalizing to ignore. The search for life on Europa isn't just about finding aliens, it's about understanding the potential for life in the universe. It's about pushing the boundaries of our knowledge and exploring the unknown.